Good afternoon all. In the last class we have seen single layer perceptron models. So in today's session we will extend the topic and we will see the single layer perceptron models and training algorithms. The perceptron learning rules. So how that perceptron need to be trained, that we need to see, then only we can give for the given inputs we can get the required output. So we no need to design the particular networks or particular perceptron model. What we need to do is we need to learn the weights, then those weights and thresholds, how to change those weights and thresholds. If we know that properly, then we can get the required output. Just by showing it to the correct answers, we want to generate the same output. That means by changing the weights and thresholds for the given input, we need to get the required output. The required output need to be produced by the user, it should be given by the user. Then to get that required output, every time we need to verify the obtained output. If it is not matching with the required output, obtained output is not equal to the required output, then we need to adjust the weights and thresholds. So for example, let's input will be x is equal to I1, I2 and so on In, where each input may be either 0 or 1. In that case, the output also either 0 or 1. So by assuming like this, how that perceptron learning rules will be framed. So algorithm for the perceptron learning is nothing but just give the input x is equal to I1, I2 and so on In. That may be 0, 1, 0, 0, 1 and so on. So each input may be either 0 or 1. Likewise, if it is n vector means n by 1 vector means, then in that case you get either 0, 1, 0, 0, 1. Vertical way you will get the points for the n input neurons. So by giving that input x, perceptron produces the output y corresponding to the input. The output will be generated and will get the corresponding output from the perceptron. But what we need to give is, we need to tell the perceptron that the correct output is, let us assume that as O. Now we have given the correct output, that is nothing but required output. Required output is here O and the obtained output is Y. With the given inputs, weights and threshold, initially what we were assumed with the weights and threshold, you obtain the perceptron obtain some output Y, but our required output is O. If we had wrong answer or if we didn't get the required output like O, then we need to change the weights. WIs means we need to change the weights and threshold theta, otherwise no change in weights and threshold, because obtained output is equal to the required output. Required output means no need to change the weights and thresholds. But if it is not means, then we need to change that weights and threshold till we obtain the required output or correct output. So still if we go further, what is the motivation for this weight change rule, or what is this weight change learning rule means? Let us assume in detail. If we see, if output y is equal to 0, that is output y is nothing but that is obtained output for the random weights and random threshold, the obtained output is y, which is equal to 0. But the correct output O is 1. What we required is 1. That is the correct output. Our required output is O, which is equal to 1. Then that is not the right answer. What we are expecting is 1, but we got 0. So in that case, then y is not large enough. So reduce the threshold and increase the weights doublies. This will increase the output. That means y is equal to 0 means the corresponding neurons doesn't fire. That's why the corresponding output is 0. So when that corresponding neurons will fire? When summing input, that is nothing but summation some I to n double I into xi, weights and the corresponding inputs, product of the weights and inputs, summation of product of the weights and inputs. If it is greater than or equal to threshold theta, then only the output neurons will fire. Otherwise the output will be 0. Fire means it will be 1, otherwise it will be 0, right? Y equal to 1 when summing input or the sum of the product of the double I into xi, double I xi should be greater than or equal to theta, then your output equal to 1. But here in the first case, at the first point, your output y is equal to 0 means that is less than theta. If it is less than theta means your theta is more than the sum of the summation of I double I into xi, right? Summing input. So in this case, what we need to do? Either we should reduce the theta value to satisfy that condition, that is greater than or equal to theta. Summing input should be greater than or equal to theta. To satisfy that, either we need to reduce the theta value or we need to increase the weights. If you increase the weights, what will happen? The increase in the weights will be multiplied with the inputs and your overall summing of the product of the double I and xi will increase. So if double I xi product summation of double I xi, if it increases means that will become greater than or equal to theta. In that case your output will become 1. Okay, so that's what we need to do if you are not getting the correct output like the required. Here y is equal to 0 but your O is equal to 1. That's why you need to reduce the threshold and increase the weights to fire that corresponding neuron. That means the summation double I xi should be greater than or equal to. To make that one, we are doing this process. Here we need to observe one thing: the inputs cannot be negative. But so high positive weights means high positive summing input will get it, right? Here, if your weights are more means weights are multiplying with the input means you will get the high summing input. So in this case, why not just send the threshold to the minus infinity? That question may come. You can keep simply, instead of changing the weights, we can keep simply the threshold can be minus infinity, so that for any value of the weights, your summing input always greater than that theta, which is minus infinity. Like that we can assume, right? Then always the output will be definitely equal to 1. Or either threshold can be minus infinity or your weights can be, we may get the questions like this, or send the weights to the plus infinity. If your weights are also infinity means your summing input always it is always greater than that threshold only. But here we need to understand one thing: only we need to increase the weights along the input lines that are active. That means which input lines are active, those lines weights only we need to, the associated weights only we need to increase. It means if your input is equal to 0, what is the purpose in changing the corresponding connection link weight? Anyway, 0 input is multiplying with the corresponding weight, whatever the value it may be of that particular connection line weight, that is equal to 0 only. That product is equal to 0, double I into xi. If let us take w1 into x1. If x1 is equal to 0 means, irrespective of your w value, your product will be equal to 0. In that case, no meaning in changing the weight values. That is where I is equal to 1. That is input Ia is equal to 1 means input is equal to 1. If Ia is equal to 0, for this example, then the weight Wi had no effect on the error this time, because whatever the weights are multiplying with the corresponding inputs will be equal to 0 only. So it is pointless to change it. Okay. For other inputs, that maybe works fine. The corresponding associated weight we can change to get the required output. But for the inputs 0, the corresponding neurons connection weights no need to be adjusted. Necessarily we no need to increase the complexity in the functioning or performing that network perceptron working. So that we need to remember. Further, if you see, similarly, if y is equal to 1 and required output y is equal to 0, obtained output y is equal to 1 but required output y is equal to 0, then the output y is too large. That's why output is, that is output y is nothing but summation of double into x, right? So the output y is too large than the threshold theta. In that case, we need to decrease the output y, that is nothing but summing input, or we need to increase the threshold value theta. So either we can increase the threshold value or we can reduce the weights of the connection link so that your summing input will be less than theta. In that case, your y will become 0. So that's what we need to do. In other case, if both the required as well as obtained weights are same, in that case, that is if y is equal to 1 as well as o is equal to 1, or y is equal to 0 as well as o is equal to 0, then there is there is any requirement to change that weights or threshold values. Hence, no need to change that weights or thresholds. So as it is, the weights and thresholds will be there to get the required as well as obtained weights as it is. In this case, further if you modify that algorithm, the algorithm will becomes like this. So for the given input, whatever the first line, that may be repeated if condition is not satisfies. So I repeat forever like that. That is in the loop. Repeat forever means that is in the loop. In that loop, given input x is equal to I1 to In, that is the input vector, and perceptron produces the output y, that is the obtained output, and we are told that the correct output is O, that is the required output. For all I value, which is nothing but I is equal to 0 to n, your Wi, which is nothing but weight, Wi is equal to Wi plus C into O minus y in bracket into Ia, and theta will be, theta is equal to theta minus C into 0, that is nothing but O minus y. So where C is some positive value and here it is called the learning rate. See here, if you want to increase the weight means you have to go for, see we have seen when y is equal to 1 and O is equal to 0, one case, that is you have to reduce the weights. If y is equal to 0 and O is equal to 1 means, in that case your weights need to be increased and threshold value need to be decreased. So based on that you have to choose that plus or minus sign in the equations wi and theta. If you need to increase the weight means we have to go for wi plus c into o minus y into ii. So here if we need to remember one thing, that is the threshold is length as well as the weights. Threshold as well as weights need to be learned from the algorithm. So if O is equal to y, there is no change in the weights, right? If O is equal to y means O minus y in both the equation it is equal to 0. So in the first case wi is equal to wi only, theta is equal to theta only. No change in the weights and threshold. If even if Ii is equal to 0, that is any one of the input, let us take I is equal to 1 to n, like that we have taken, right? If I1 or I2 equal to 0, then there is no change in the corresponding connection link weight, that is W2 or W1. So here when O is equal to y, there is no change in the weights, first case, there is one condition, and also for thresholds. And when Ia input equal to 0, in that case also we need to change the weights of the connection links. To understand more about these learning rules, let us take one example. In this first column is input, this x vector. Let us take a network fires or not, that is nothing but output y, and the required output or correct answer or correct output is O, capital O, and what to do with the weights and what to do with the threshold theta are the last two columns. In the let us take that is input vector x is nothing but 0 1 0 0. So each input neuron, one first input is nothing but 0, second input is 1, third input is 0, fourth input is 0. In that case the network's fires are not is nothing but, let us assume that the network y is the summing output, that is nothing but y is equal to 0, but the required output is, or correct answer is 1. To get the required answer or correct answer, what we need to do? We need to adjust the weights and thresholds. What to do with the w sin theta means we need to increase the weights, because y is equal to 0. We have to make that y is equal to 1. To make that y is equal to 1, like the required or correct answer 1, what we have to do? Your y should be greater than or equal to theta. Y is nothing but sum of the summation of wi into xi. In that we can increase the weights. Your input is as it is, but you can change the weights. That's why you need to increase the weights. To make the wi xi summation wi xi greater than or equal to theta, either you need to increase the weights or you need to decrease the right side theta. That's what we need to do for the first input. Increase the w corresponding weights as well as reduce the theta. Likewise, if you see the second row, the second set of inputs, that is 1 0 0 0. In that case also your network's output is 0, but required output is also 0. Correct answer, that is second column, is also 0. In that case, when it is y is equal to O, no need to change the weights and thresholds. That's what the last two columns. But for the third set of inputs, 0 1 1 1, in that case your network's fires are not, that y is equal to 1, but the required answer or correct answer is 0. Even though the output neuron gives some value, that is output y is equal to 1, but the right answer is 0. In that case, what we need to do? Y should become 0. To make that y equal to 0, what we need to do? Y is equal to summation wi xi. In that, what is a variable? Only w we can change in our hand. So we can reduce the w. To do not fire means, what we need to do? We need to make summation of wi xi should be less than theta. To make that less than theta, you need to reduce the left side value. Left side value is nothing but summation wi xi. In that, input is fixed, but w you can change, so that you need to reduce the w. right side value you need to increase. That's why you can increase the theta value so that your y will become 1. So your y will become 0, which is equal to the O value. Likewise, the remaining cases. So if all 4 ones are the input, the last part one row, there is 1, 1, 1, 1. So your output is equal to y is equal to 0, but your right answer is 1. It is similar to the case like the first row. You need to increase the weights as well as you need to reduce the theta. If both y is equal to 1 as well as O is equal to 1, then there is no change in the weights and theta. So for to see the in detail algorithm, the fixed increment perceptron learning algorithm for a classification problem with n input features. N input features, that is x1, x2 and so on. Xn is the input layer vector and the output classes are either 0 or 1. In this case, the algorithm, already we have seen this algorithm, but in detail the algorithm looks like this. In the step 1, we need to create a perceptron with n plus 1 input neurons. And why n plus 1 means 1 can be taken as a bias. So in the n plus 1 input neurons, x0 to xn, right? In that x0 can be 1, which is a bias input. Let O be the output neuron, capital O be the output neuron or the required output. So initialize the weights with some random value. Weights W vector is nothing but W0 to Wn, the corresponding input associated links weights W0 to Wn, that you can initialize with some random value initially. In the step 3, iterate through the input patterns xj. For the first set of, let us say xj vector means j is equal to 1 to or j is equal to 0 to n, or j can be 1 to n. For the first set of inputs, j can be any number of sets. If it is first set means x1 set, in that case xj1, xj2, xj3, that is first set of inputs. For that, the corresponding weights what we were initialized with the random values will be taken as it is and compute the corresponding weighted sum of the inputs for the particular j input set. That is, j may be 1, 2, first set, second set, third set, like that. That will become summation I is equal to 0 to n xi into wi for each input pattern j. Each input pattern j. So here the summing input will be for the first set of inputs. The summing input will be summation I is equal to 0. That is x0 into w0 it will become. Next case, likewise for each set you will get the summing input. In the next step, compute the output yj. For the first set of inputs, you will get the corresponding first set of output yj. J is equal to 1 means here y1 will be it using the step function, and here yj is equal function of that net j. Net j is nothing but summing input. That is equal to 1 when summing input net j is greater than 0. Here threshold value is 0, is greater than or equal to theta. Theta is equal to 0. Else it will be 0. That is nothing but if it is less than 0 or less than theta, then yj is equal to 0. So in the next step, compare the computed output yj for the corresponding input pattern j. The obtained output is yj with the targeted output o. Actually, that is o. The targeted output o for each input pattern j. So I think both obtained output is yj as well as target output is also yj. As mentioned, but compare the computed output yj with the targeted output o, capital O, for each input pattern j. If all the input patterns have been classified correctly, the output weights and threshold no need to change, and the program can exit or the computation can be exit. It means your y is equal to capital O, then no need to change the weights. Otherwise, what we need to do, we need to update the weights as well as the threshold in the next step. So if the computed output yj is 1 but should have been 0, it means it is opposite. Yj is not equal to the O, capital O, that is obtained is not equal to the required. In that case, what you have to do when yj is equal to 1 means that should be 0. To make that 0, you need to reduce the weights. That's what I is equal to I minus alpha into xi. Alpha into xi, where I is equal to 0 to n. We are reducing the weight with learning parameters alpha. If computed output yj is equal to 0 but should have been 1, so your obtained is not equal to the required here also. In that case, your obtained is 0 but it should be equal to 1 means what you have to do, you have to find the corresponding output neurons. For that, what you have to do, you have to increase the weights. So here I is equal to I plus alpha into I, where I is equal to 1 to n. So here we have fixed the threshold value and we are updating only the weights, connection weights. In both the equation, alpha is the learning parameter and it is also constant. Here theta is also constant. Only by adjusting the weights of the connection links only we are trying to get the required weight. In the next step, this can be repeated for each set of inputs layer. That's why in the next step go to the step 3. That is first set of input like 0 0 0 0 1 0 1 2 3, some number of values you can take for that particular set of inputs from 0 n values n by 1 vector. All 6 steps will be processed, then it will go to the step 3 again. Step 3 means again is iterate the input parameters xj. If earlier it was x1 means now it will be the second set of inputs x2, and the steps will be followed. Again it will go to the last step, that is go to the step 3. Again step 3 means it will go to the step 3 and third set of parameters. If it earlier x1 x2 means now it will become x3. Like that, how many set of input parameters are there, we need to send those many steps. The same iteration will be repeated. Steps will be repeated from the step 3 to step 6. After j exceeds the or j is equal to the set value, j is equal to n or j is equal to m, then the program will end the computation. So if you see, the convergence proof exists. That means when the learning algorithm will converge means if the exemplars used to train the perceptron are drawn from two linearly separable classes. This linearly separable classes we have seen, and it is linearly separable because we can separate with some planar one on one side and remaining three points on the other side, that we have seen the quadrant diagram. So here also, if the exemplars used to train the perceptron are drawn from two linearly separable classes, then the perceptron algorithm converges. If it is separable firing zone as well as non-fire zone, then the algorithm converges. There it will end. And the positions the decision surface in the form of hyperplane between the two classes. Two classes, nothing but one is firing zone and the other one is non-fire zone of the neurons. So example in 2 dimensions, let us take, if we start with the drawing a random line between the x1, if it is x1 is on the x-axis and x2 is on the y-axis, and if it is 2 input you get like the combinations are 0 0 0 1 1 0 1 1, what we have seen in the last class. So you can draw some random line. Some point is wrong side. Instead of falling particular point on the right side, it falls on the left side. Then what do you need to do? You need to draw another line. You need to shift that line towards that correct place. Some other point is now still it is on the wrong side. Then we need to shift the line again, and so on. So shifting means again we are adjusting the weights such that your line will shift slowly to linearly separate those points, and it will give the to draw the hyperline between the two classes. Until the line separates the points correctly, the program will run and it will not converge. Once if it is separable, then it will converge. So that's for this learning algorithms. Thank you all.